Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for October-November 2024, paper 3-3, and this is part 1 for questions 1 to 6. Question 1 is coming from complex numbers. So the complex number z satisfies the modulus of z, which is equal to 2, and the argument of z ranging from 0 to pi over 4. On an Gann diagram below, sketch the locus of the points representing z. And then part B, on the same diagram, sketch the locus of the points representing z squared. First of all, the first one here, this is a circle, center 0, 0, then radius is 2. And then this is a half line, which is starting from the origin, and then it makes an angle of pi over 4, okay, to the horizontal. So usually I always show this one here. So z here, if you see the modular signs on one side of the equation, you should know that that is a circle. So we create a negative. This is 0 plus 0i, not to change the meaning. So that means here you will have your circle of radius 2 and center 0, 0, okay? Then if we have 0 less than or equal to the argument of z, then less than or equal to the pi over 4, we also create a negative. It will be z less than or equal to the argument of z, then minus 0 plus 0i. You see? Then less than or equal to pi over 4. So here we are going to have a half line, okay, starting at the origin 0, 0, the one you have gotten here, okay, because not every time that the half line is starting from 0, but if you have argument of z without anything, they can give you argument of z maybe minus 1. That means you will have z, then minus, so you will have 1 plus 0i. So that means that half line is beginning from 1, 0, that point 1, 0. You see? So that is that. Now, then they have also given us z squared here. We also sketch the locus of z squared. So they have to be on the same diagram. So meaning for z squared, if we have the z values which are negative, when we square them, they become positives. Okay? So if we have z squared and then the modulus of this z here, z squared, okay, this one is actually the same as saying we are also going to square the radius. So when we square the radius, this one is going to be a 4. So meaning we are going to have a circle of radius 4 and then center 0, 0. But actually here we are not going to have a circle. It is going to be an arc, because if you have a circle like this, it has gotten z values which are negative, but they have been squared and they are positives. You see that? So we are going to have an arc, not a circle. So I'll come to this one here and then I'll draw. So on this axis here, I will put 1. Okay, maybe this is 1, this is 2, this is 3, this is 4, this is 1, this is 2, this is 3, then this is 4. So I'll draw an arc of this passing through 4 and 4. Remember, the radius is 4, the center is the origin. So the radius here is 4, and then here is also 4. Okay? All right. In fact, let me just use my compasses here and everything to be plotted perfectly. So I'll get my ruler to measure things very well. But this is just a sketch, so even if you don't be so perfect. They give you the marks. Okay, so I'm going to have 1 here, then 2, 3. So like that. Now I'm going to get my compass. This one, the arc, one of the arcs has to be to 4 centimeters, and mine can measure up to those 4 centimeters. Then I put at the center here, okay, just like that, and then I can draw an arc from here up to there. It shouldn't actually exceed this 4 here. It shouldn't exceed this one here, so it has to be there, just like that. Okay, and then the other one has to be an arc of 2. The radius is 2. Okay, so I'm just going to duplicate this one because my compass here cannot stretch up to 2. Okay, it cannot go up to 2. It ends at 3.4. So what I will do is just to diminish this one. Actually, let me just leave this one here. Then I diminish this one. Then it such that it cuts at 2 and 2. Like that. That is what I'm going to have. Now, I'm going to bring back my compass here. Stretch it up to the 4 there. And then I draw the other arc for the z squared. So it will be like that. So that is that. So that is for z squared, the big one, and then the smaller one is for the z. Then I'm going to measure 45 degrees because the other half line is supposed to begin from the origin and then within 45 degrees. So when I bring my protractor to measure the 45, so just put this one there. And then our 45 is here. So just like that. Then I can take this one off. And this is going to be our answer here. So we need the points that are on those circumferences. Okay, and also on the half line. So we are not shading anything that we are shading here. No. It has to be that. Actually, let me show you something here. Okay. If I represent the z here in the polar form, z, remember, is a circle. This is a complex number. The radius is 2. So it can be z, which is equal to 2, then e to the power of pi over 4. Okay, we can write it like this, pi over 4, then I. So now the arc here, z is of radius 2, but this z is not supposed to go beyond this line that I've put here for 45. Okay, so that means we shall pull off this part here. I'll pull off this part here, and it has to remain here because all the points that are on this circumference here are making an angle of 45. Okay, it's like a slice of the pizza, okay, or the slice of a cake, just like this here. Okay, but then when we come to z squared, why is this one 4? The better explanation is actually this one, that I have z, which is equal to, if I square z, this one will be 2 squared, then e power pi over 4i, then I also square this one here. So meaning z squared is going to be equal to 4, then e to the power of course, using rules of indices, this pi over 4 will multiply with this 2, and then we get pi over 2. So meaning the z squared is going to have its argument as pi over 2. So that is why we are drawing this arc from here, and then it makes an angle here of 90 degrees. It's a quadrant for it. Okay, so that is what it is going to be. So this arc here is 2 times this one here. Okay, the radius is 2 times, and then the angle it also forms is going to be 2 times the angle this one forms here. So we are picking those z those points on the Z that are exactly 2 units from the origin here, 0, 0, and they will be on this arc here. You see that? So that's why we are not drawing a full circle. It is just an arc. Okay? It is just an arc. The Z points must be exactly 2 units from here and must not exceed an angle of 45. So this is the angle of 45. Okay, here we are saying 0, then less than this. Yes, I can put a point that is inside here, but again, this point is not exactly 2 units from the center here. It is still its length here is less than the 2. So that's why we are taking an arc. Okay, it has to be an arc. So both of these ones are going to be arcs. So just like that, that is what we are going to have. Question 2, let f of x be equal to 2x cubed minus 5x squared plus 4. Show that if a sequence of values given by the iterative formula, this one, converges, then it converges to the root of the equation of that f of x, which is equal to 0. So the only thing that you have to do here is rearrange to get back the f of x, as simple as that. So rearrange this to get the f of x. So you drop the n's in here, because here the x's, they don't have the n's. So I'll have x, which is equal to the square root of 4 out of 5 minus 2x. Now we can square both sides. So square both sides. That means here I will have x squared, which is equal to 4 over 5 minus 2x. Then when we cross multiply, we shall get 5x squared minus 2x cubed, which is equal to 4. Okay? If I take everything this other side, because I can see that the 2x cubed here is positive. So this simply implies that we shall have 2x cubed. Then the 5x squared is going to be a minus when it crosses. Then you find the 4 there, which is positive, is equal to 0. And this one is out, what we are looking for. So in numerical methods, remember we are supposed to solve these equations that cannot be solved using the usual algebraic methods. So in doing so, here we are having 2 x's. So they make one the subject of the formula. But the 2 formulae that you are going to get, one converges and then the other one diverges. The one that converges is usually the one they give you to prove that it converges, okay? By just rearranging it, as simple as that. Converging means that when we put in the values and they iterate, okay, we iterate, these values are tending to a certain value, okay? There is consistency within the values. But the one that diverges, you get a value here, then when you put it in again, you're going to get a far different value like that. So there is no consistency within the values. That is what we call divergence. Then part B, they're saying that the root, the equation has a root close to 1.2. Use the iterative formula from part A and an initial value of 1.2 to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So if our x1 here is 1.2, so by substituting in the formula that is given, our x2 is going to be equal to the square root of 4, then out of 5 minus 2 into 1.2. Wherever there is x, then we put this value that we have gotten here. So in your when you put in your calculator, what do you get? Square root of 4, then divide by 5 minus 2 into 1.2. So we get 1.2403. 1.2403. And then what will be our x3? Okay, I don't need to write all of these other ones showing the substitution here. So I just need to go back and I substitute in the calculator, okay? So where there is x here, I'm going to put now this value here. Don't put here answer in your calculator, okay? many times it fails to give you the final answer that is required. So you just substitute this value to 4 decimal places that you have gotten. So the next one here, we are going to put 1.2403. 1.2403. That is 1.2600. 1.2600. Then we can continue and we put another one. If we put in this 1.2600, what do we get? 1.2600. Now we get 1.2700. 1.2700. Then we can proceed. 1.2700. That is 1.2752. 2752. x5 is equal to 1.2752. Then the next one, come back here and you put 1.2752. 27. So x6 is equal to 1.2779. How do you know that you're supposed to stop? First of all, to 2 decimal places, this one is giving us 1.27. Then this one is giving us 1.28. This one is giving us 1.28. So these are the minimum number of iterations I must do when I get 2 values that are giving me the same answer. So this is the minimum. So how many times have I iterated? 1, 2, 3, 4, 5. Okay. So in case they ask for the minimum number of iterations you're supposed to carry out, for this case, it is going to be 5. Okay. Now, I'm going to put another one. It is a confirmation. They have to be 3 values that are rounding off to the same value. Okay. So 2779. 2779. Then it gives us 1.2793. 1.2793. Now these 3 are all giving the answer 1.28 to 2 decimal places. So that means our x here is 1.28. Like that. In question 3, the number of bacteria in a population P at time t hours is modeled by the equation P is equal to A, then e power kt, where A and K are constants. The graph of natural log of P against T shown in the diagram has the gradient 1/20 and intersects the vertical axis at 0, 3. Now, we are told to state the value of K and find the value of A correct to 2 significant figures. There's something very important here you need to know. Always look at what they have put on the axis. This is natural log of P and this is T. That means when we reduce this one into a linear form, or if we have coordinates, we should know that the x coordinate will be the T, the y coordinate will be the natural log of P, not just P. Will be natural log of that. Okay. Now we have this P here, which is equal to A e power kt. We introduce logarithms on both sides. So natural log of A, then e power kt. Now using the rules of logarithms, since this is multiplication of those powers, then it comes from addition of logarithms to the same base. Okay, so we shall have natural log of P, which is equal to, this one will come down here. That is also a rule in logarithms. So kt, and then natural log of E, then plus the natural log of A. So we shall have natural log of P, which is equal to kt, because natural log of E is 1, then plus the natural log of A. Now this one is in the format y is equal to m, let's say x plus c, the linear equation. So this is the gradient here. Okay, and then this one here is the horizontal axis, which is the t given. So meaning k is the gradient. So since k is the gradient, then k is going to be equal to 1/20. because it was given here the gradient 1 over 20. So as simple as that. Then, since we also know where this one cuts, where the line cuts the y-axis or the vertical axis, that is the same as this natural log of a. So we shall say natural log of a is equal to that 3. So therefore a is equal to e power 3. Okay. Remember, in logarithms we have log of a b is equal to c. It's the same as a power c is equal to b. Okay. A power c is equal to b. And this is the natural log, so which is the same as log e, then a is equal to 3. So we shall say e power 3, which is equal to a. So what will be our a to two significant figures? This is e power 3. That is 20.08, and whatever is coming forth, but then to two significant figures, we shall have 20. Remember, 0 is a significant figure if it is in between other figures, and the two zeros we are seeing there all are significant. Okay, because they are enclosed within other figures. So a is going to be 20. Part B. Find the time taken for p to double. Give your answer correct to the nearest hour. Now, if p doubles, then the initial value of p is multiplied by 2. Okay? The initial value of p is multiplied by 2. So for t, that is equal to 0. We have p, which is equal to a, then e power k times 0, because remember it was kt. So this one is actually equal to a, because you know that anything power 0, a number power 0 is always a 1. Now, if p doubles, this then means that p shall be equal to 2a. Okay? Because the initial one, p, is a. So now when it doubles, then it will be 2a. Now, since p is a e power kt, then I will equate this one to a. In other words, I'm just substituting here. Okay? Our a is going to disappear. We are going to remain with e power kt, which is equal to 2. Okay? Now, we have to make t the subject of the formula, so we introduce natural logarithms on both sides of the equation. So this will be natural log of 2, and then this one will come down here. Then we shall have kt, which is equal to natural log of 2, and then t becomes natural log of 2, then divide by k. Okay? And what is k? K is 1 over 20. So if you have 1 over 20, then this one will somersault and go up. That means we shall have 20 natural log of 2. Okay? They said correct to the nearest hour. So what is 20 natural log of 2? 20 natural log of 2. This one is 13.8, but they said to the nearest hour, so I'll write 14. So t is equal to 14 hours. As simple as that. Question 4 is also coming from complex numbers. The complex number z satisfying the equation is this one here. Give your answer. We are supposed to find a complex number z satisfying this equation and then give the answer in the form x plus iy, where x and y are real. Okay. Now, here I can let since my z is x plus iy, I can cross multiply here. And then we have 5 into z is x plus iy. Okay. Then minus 3 I. Then this one is going to be equal to z is x plus iy. Then it is, okay, there is a plus 3i. Then after that, remember it is this one now times that. So we shall have 2 minus 9i. Okay. Now we can open, actually here I can have 5. Okay. 5 of x, then plus 5. The imaginary here is y minus 3. So y minus 3 of I. And then when we go to this side, we shall have x here times the 2. So that will be 2x. And then we have x again times this one. So we shall get minus 9xi. Then here we have y plus 3 of I. times the 2, okay? Y plus 3 of I times this 2. And then we also have Y plus 3 of I, then times the negative 9I. Remember, I squared is always equal to negative 1. Now, I'll have here 5x, then plus 5y minus 15 of I, which is equal to, this other side I have 2x, then minus 2xi. When I open here the brackets, I'll have plus 2y plus 6, and again I, and then here I squared is a negative, so there is also a negative there. It is going to become a plus, so we shall have 9y then plus the 27. Okay, 9y plus 27, because remember this one is multiplying with everything here. Now I can have 5x here, then plus 5y minus 15 of I. I can separate the real from the imaginary. So we have 2x plus 9y plus 27. And then the imaginary is going to be 2y plus the 6. And then minus the 9x. So I'm putting all of these together because they have the I on them. Now we are going to equate, because complex numbers are said to be equal if the real parts and the imaginary parts are equal. In other words, if the real is equal to real and then the imaginary is equal to imaginary. Okay, so equating these parts, we shall have here 5x, which is equal to the 2 of x plus 9y plus 27. You see that? Then we can actually simplify this, bring this one here. I can have 3 of x, then minus 9y, which is equal to 27. We can divide all through by 3, and then we get x minus 3y, which is equal to 9. That is equation 1. Then how about the imaginary parts? We have 5y minus 15, then is equal to 2y plus 6 minus 9x. You see that? Now, we bring everything this side, and we also form another equation. So 9x, then when this 2y comes this side, we shall have 3y. So 5y minus 2y, that is 3y. Not so? And then we take this one, this other side, the 15. So 15 plus 6, that gives us 21. That means when we divide all through by 3, we shall get 3x here, then plus a y, which is equivalent to, no, actually I'm going to leave this one here such that it becomes easier for me to solve. So this is the second equation. Now solving 1 and 2 simultaneously, solving 1 and 2, we can have x minus 3y, which is equal to 9. The other one is 9x plus 3y, which is equal to 21. Do you see that when I add these two, this y will disappear because one is negative, the other one is positive. So x plus 9x, this one is going to give us 10x. 9 plus 21, this one is going to give us 30. So meaning when we divide all through by 10, our x is going to be equal to 3. Then we can either substitute here or into this one to get the value of y. So by using equation 1, I will have 3 minus 3y, which is equal to 9. So bring this 9 here, it will become a minus. So 3 minus 9 is going to be equal to 3y. So meaning y shall be equal to negative 6 over 3. So y becomes a negative 2. Okay. So this simply implies that z, okay, our z is going to be equal to 3, then minus 2i, just like that. Number 5, part A, show that cos power 4 of theta minus sine power 4 of theta, then minus the whole of this is that. So what we are going to do here, for these two, I'm going to use a difference of 2 squares, okay? Using a difference of 2 squares. And this one states that if I have a squared minus b squared, this is the same as a plus b, then into a minus b. So I'll have my cos power 4 of theta minus sine power 4 of theta. It is actually the same as saying cos squared of theta squared, then minus sine squared of theta squared. So this one is going to be cos squared theta plus sine squared theta. Then here cos squared theta minus sine squared theta. Now this one here is a 1, but then this one is cos 2 theta. Okay, so here we are having cos 2 theta. So meaning the cos power 4 theta I'm given minus sine squared, sine power 4 theta, then minus 4 sine squared theta, cos squared theta. This one is going to be the same as cos 2 theta, then minus 4 sine 2 squared theta cos squared theta. But also here we can see that this one is the same as 2 sine theta cos theta. There is a double angle for sine here, squared. So this one is a perfect square, this one is a perfect square, and this one here. So that means I'm going to have cos 2 theta, and this is the double angle for sine. So minus sine squared 2 theta. You see that? Now, since what I'm doing here, I have cos 2 theta. I don't have any sine 2 theta. I'm going to use the Pythagorean identity of trigonometry. So cos 2 theta minus, this is 1 minus cos squared 2 theta. Okay? Then, opening the brackets, we shall have cos 2 theta minus 1, then plus cos squared 2 theta. So meaning our answer is going to be cos 2 theta plus cos squared 2 theta, then minus 1. Just like that. Now here they are saying part B, solve the equation, this one here. So what I'm going to have is, I'm going to bring this one here, this side. Okay? So we are going to have cos power 4, 2 theta, 2 alpha, then plus cos 2 alpha, then minus the 1 here, which is equal to 0. Okay? Remember, when I bring this one this side, it is going to resemble what I've just proved. Okay? Let's check again. What we have just proved is here. This whole thing on one side. Do you see that? That. And then here we have twice theta, twice theta. So that's why here I'm having twice. I have twice alpha also, just like that. Then this is a quadratic in cos 2 alpha. So I solve this one. You have to show the examiner that you solved. Okay? So since this one is not factorizable, you show that you have substituted in the quadratic formula. So minus b plus or minus to the root of b squared minus 4ac. Okay? Then out of 2a. So 4 plus 1, that is a 5. So this one will be negative 1 plus or minus root of 5 over 2. So meaning our cos of 2 alpha is going to be equivalent to negative 1 plus root of 5 over 2, or cos of 2 alpha is going to be equivalent to negative 1 minus root of 5 over 2. This one is beyond negative 1, and you know that cosine of any angle is always ranging from 1 to negative 1. So therefore, this one here is undefined. So our 2 alpha is therefore going to be equal to the arc cos of negative 1 plus root of 5, then over 2. Okay? Then we'll put this one in the calculator. So cosine is negative, I mean positive, because this value here is positive. Root of 5 is 2 point something, so minus 1, it is going to be a positive. So we have A, S, T, and C. The domain is given, the domain is given in degrees. So this is 0, then 360. When you come back, this will be 90 degrees. This is 180 degrees. This is 270 degrees. So we are picking from here and here where cosine is positive. You see? So this will be 360, then minus theta, if this one is theta. So 2 alpha, remember this is 2 alpha. So, but we need alpha, so after we shall divide by 2. So arc cos of this one here, what do we get? The calculator must be in degrees, so shift, then arc cos, we shall have negative 1 plus root of 5. Down here we have a 2, and then we shall get 51.8. You can even write to 2 decimal places. Okay, then you round off at the end because there is dividing by 2. So 51.827. We can write 51.827. And then you also write the other angle where cosine is positive, which is 360 minus that answer. So 360 degrees, then minus this 51.827. Okay, so our alpha is going to be a half of this 51.827 and also a half of this 360 minus the 51.827. So what do we get as our final answer? So we are going to say a half of this, so 0.5 times that. That one will be 25.9 whatever, but I'll take to 1 decimal place, 25.9. 25.9 degrees. And then the other one is going to be, remember it is 360. Okay, then minus that angle we got, then after we divide it by 2, that's why I've left the 0.5 here. Okay, so we get 154.1. 154.1. This is all to 1 decimal place. Number 6 is coming from vectors. The lines L and M have Number 6 is coming from vectors. The lines L and M have vector equations, these ones here. They say that lines L and M intersect at the point P. State the coordinates of P. Now, just state, it is even 1 mark. That means you have to look at the 2 and you identify the common point. So for L, we can see its R1, which is equivalent to 2I plus J minus 3K. Okay, minus 3K. In fact, not to waste time, it's just a matter of seeing here. This point here, they all pass through this point. This one is the same as this one here. Remember, a line, you are beginning from the origin, you go through a point, there's another point that you know, and then there is an arrow somewhere. Okay, so there is a common point, that one there. So that means that common point P is going to be 2, 1, negative 3, as simple as that. Part B, find the exact value of the cosine of the acute angle between L and M. So here we find the angle between the directional vectors of the 2 lines, okay, using the scalar product. So D1, you just look at what is inside the brackets. So let's say the D1 or the D of L, line L, is going to be negative I, so that is negative 1. There is no J, so it is 0, then the 2. And then the directional vector of line M is 2, negative 1, 5. Okay, then from there, using the scalar product or the dot product, using the scalar product, we shall have d of L dotted with d of M. This one will be the modulus of d of L, then times the modulus of d of M, then cosine of theta. So meaning cos theta is going to be equal to the dot product of these two. Okay, the dot product of these two. Then we divide by their magnitudes. So like that. So let's dot -1 here, 0, 2. You dot it with 2, -1, 5. And then you divide by the square root of -1 squared plus 0 squared plus 2 squared. Then times the square root of 2 squared plus -1 squared, then plus 5 squared. Okay. Then I multiplies I, j with j. So this with that, this with that, and this with that. So we are going to have -2, then plus 0, then plus 10. Then down here, we are going to have 2 squared is 4, then plus 1, that is root of 5. Then here times 25 here plus 4, that is, in fact, plus 5. That one gives us 30. Okay, so we shall have root of 30 here. So therefore, cosine of theta is going to be equal to, this will be 8. Root of 5 times root of 30. Root of 30 is the same as root of 5 times root of 6. Now, root of 5 times root of 5 is 5, so I can say 5 root of 6. Then they are saying part C that the point A on line L1, on line L has coordinates 0, 1, 1. The point B on line M has coordinates 0, 2, -8. Find the exact area of the triangle APB. Let me make a simple sketch here. Maybe this is one line, let's say line M. Then there is another line here. Let's say this is line L. So I can have a point A here, which is 0, 1, 1, because it is on the line L. And then I can maybe have here point B on the line M, which is 0, 2, -8. And then there is a point of intersection between these two lines, which we have seen right away from here that this point, which is common, is P, which is 2, 1, -3. Okay, so 2, 1, -3. I'll write it also here, 2, 1, -3. Okay, now these two have gotten an angle of intersection between them. So let me just connect this one here. This one doesn't mean that this one is, vertical. Okay, it can be slanting. This is just a sketch. All right. Now, for any area of the triangle, so long as we know two lengths and the angle in between, then we can get the area of the triangle. So we need to find the length of this one here, the length of this one here, the angle. We can also get it, sine of that angle. Okay, so what is PB? PB here is going to be equal to the square root, change in x, then change in y, and then change in z. So PB, we shall have 2 minus 0 squared, then plus 1 minus 2 squared, then plus -3 minus -8. So that will be plus 8 squared. Okay, so what do we get here? This is 4 plus 1, that is 5. This one here is 25. So 25 plus 5, that one gives us 30, right? So this one will give us root of 30. Then how about PA? What is the length of P and A? So we shall have the square root of 2 minus 0 squared, then plus 1 minus 1 squared, then plus -3 minus 1 squared. So this one here is 4. Of course, this one is 0, and then this is 16. So that will give us 20. So it will be square root of 20. Okay. Area of a triangle which is not right angled is a half AB sine C. Now we need to get sine of the angle here, but remember we have cosine of the angle. Cosine of the angle, we got it as, let's check here again. We got it as 8. It was 8 over something. It is here 8 over root of 8 over 5 root of 6. Now, if it is 8 over 5 root of 6, you know that we are looking for sine. So sine is equal to the square root of 1 minus the cosine. Because remember, cos squared theta plus sine squared theta is equal to 1, right? And sine squared theta is going to be equal to 1 minus cos squared theta. So I can get this one from here, and I say 1 minus 8 over 5 root of 6 squared. Okay? So what do I get here when it is simplified? Square root of 1 minus, then we have 8 out of 5 root of 6, then squared. Root of 129 over 15. Now area of the triangle, is going to be equal to a half times the PA we have gotten, then times also the PB, then sine of the angle theta. So we shall have a half, then times root of 20 times root of 30, then times root of 129 out of 15. So when I put all of this in the calculator, what do I get? 0.5 times root of 20 times root of 30 times the square root of 129 divided by 15, root of 86. So the answer here is root of 86. And remember, they told us to find the exact. So we have to leave the square root there. Another person would have actually used this one here. They can use a right angled triangle, and they say cosine of theta is 8 out of, cosine is adjacent over hypotenuse. So this is the adjacent, and then the hypotenuse is 5 root of 6. And then here, this one is going to be the hypotenuse here, squared, then minus the adjacent squared, okay, using Pythagoras theorem. Let's check. Square root of 5 root of 6, then squared, minus 8 squared, root of 86. So we get root of 86. Then they will say area is going to be equal to a half times root of 20 times root of 30, then sine of theta is going to be the opposite, which is root of 86 over the hypotenuse 5 root of 6. So they say root of 86 over 5 root of 6. Okay, and by the way, this one simplified can be 20 is the same as 4 times 5, so that is 2 root of 5. And then 30 is 6 times 5, so they can say root of 5 times root of 6. You see that? And then root of 86 over, this is 5 root of 6. Now, root of 5 times root of 5, it gives you 5. So this one is going to cancel with this 5. Then root of 6 here cancels with this one here. The 2 cancels with this one here. Do you see that you remain with square root of 86? So either way, you get it. So that is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.